Welcome to Math on the Fritz with Mr. Fitz. And today we're going to be looking at our three core trig functions, sine, cosine, and tangent. And you can see I already have a few of the notes kind of labeled up here in a type of triangle that you'll see. Notice every single one of these triangles are right angles. I got a 90-degree angle here, I have a 90-degree angle here, I have a 90-degree angle here. You can only use these trig functions if we're working with 90-degree triangles. So if I look over here at the one I've labeled sine, we know that we have SOHCAHTOA, that's what we've been using as our acronym. But notice there's no labels on any of these sides. So if I'm going to use sine, cosine, or tangent, it's helpful for me to know what is my hypotenuse, what's my opposite side, what's my adjacent side. And how we're going to determine that is the angle that we're going to go off from. So I've given you a 21-degree angle here. I'm declaring that as the angle that I'm going to use in my function. Now, other than this heading being here saying it's sine, you really don't know it's going to be sine until you say, where's the hypotenuse? The hypotenuse for me is the easiest one to find because no matter what triangle I'm looking at, the hypotenuse is always across from the 90-degree angle. So I can label this side up here hypotenuse. Now, when I look at the angle that I've already chosen to be the angle, because it's the one I know, I'm going to get the adjacent side, which is made up of the hypotenuse and the other part that completes the angle I know. So I'm always going to start math off with a little enjoyment. HA, we've got to start to the problem. So I always look for where's my hypotenuse, and then whatever completes that given angle, that's the adjacent side. So I can see that the adjacent side is this part that has no label. Now clearly that's not helpful for me in this instance. I don't actually have a number on my adjacent side. So the third side, this x over here, that must be my opposite side. So now that I've labeled the three sides of the triangle, hypotenuse, adjacent, opposite, I can see that the two sides that actually have a label on them are the opposite side and the hypotenuse. Thus, the reason that I'm going to be using sine, because sine deals with the opposite and the hypotenuse. So if I just make a replacement of the given information into our general formula, I'm going to get sine of 21 degrees equals the opposite side, which is x, over the hypotenuse, which is 14. Now, we all know basics of equations. I can't just leave the 14 down here. I'm going to have to multiply both sides by 14 to get x by itself. That makes me happy. I do need a calculator, though, unfortunately. I suppose if I had a table somewhere for reference, I could look up the 4-digit decimal that goes with the sine of 21. I don't have the given table. What I have is my trusty TI-83 Plus. You could probably do this with a phone calculator as well. Whatever you have that can access the trig function. I'm going to type in 14 times sine 21, close parentheses. You can see from my display, this is what I'm looking at. And then I'm just going to hit equals, and I'm going to get 5.0171. That's way too much information. I'm looking at side lengths. The one I gave you was a whole number. So realistically, I could just call this 5. If you wanted to say 5.02, that's probably too specific for what I've given you here. So I'm just going to say x equals 5. Now, if the directions here said solve for x, I'm done. That's all I'm going to have to do. If the directions said solve the triangle, then I have to go a little bit further, do a second trig function to find out what the adjacent side is. I probably want to label this angle, but I don't have to do that. Here, the directions were just find x. We found x. If I move over to the middle triangle, you're going to notice same exact idea. I've given you an angle of 75 degrees. I can start by labeling my sides. That's very helpful for us. Anytime you're doing these trig problems, where's my hypotenuse? Here it is. It's across from the 90-degree angle. Whatever completes the given angle is the adjacent side. So I now know that the bottom is adjacent because it completes that 75-degree angle. And thus, the third side is the opposite, but I don't care about opposite because there's no label over there. So I'm looking for a trig function that uses the adjacent and uses the hypotenuse. Oh look, cosine uses the adjacent and the hypotenuse. So in order to get my answer here, I just have to plug into the cosine formula. Now there's one slight difference with this problem than the one we saw over there. If I take a look at cosine, this time the unknown I have is on the bottom. It's not on the top of the fraction. I told you the adjacent was 3, and now I have 3 divided by x. Not the funnest equation to try to figure out. So what I'm going to do is multiply both sides by x, and then divide both sides by cosine 75. The trick really, if you just want to know, well, how can I do this easily, you just flip them. But the reason you're flipping them is because you're multiplying by x and dividing by cosine 75. So my answer is going to be 3 divided by cosine 75. Probably easier to just put that into the calculator all as one step. I wouldn't really find out what the cosine of 75 is as a 4-digit decimal and then try to clear the calculator. Easier to just type in 3 divided by cosine 75. Closing parentheses. Now, I will warn you, if you're on a phone calculator or anything like that, you're probably going to have to put the 75 in first and then hit the cosine button because the calculator won't be able to understand what you're doing. So check your own calculator to see what happens. If you do it correctly, you should get 11.59. Again, I'm only going to go to maybe one decimal place here, 11.6. 11.59 is very specific, considering that the starting information was 3 feet. So I'm going to go just to the tenths place. 11.6 is reasonable because I'm talking about a hypotenuse, so I'm expecting a bigger answer. And then the last type of problem that you'll probably see as you go through your trig stuff is, what if I'm asking for an angle? What if I gave you both sides of the triangle, but I didn't give you an angle? Well, I still need to figure out, well, which one am I given? Am I given a hypotenuse? Am I given an opposite side? Am I given an adjacent side? So here's your 90. Here's h. Completing the angle that they're asking you for would be the adjacent. Again, we're starting math with a good time. Ha! We got a good start. That means the third side is the opposite. And I can now make the determination. I have an opposite and an adjacent side. Tangent is the function which deals with an opposite and an adjacent side. So I'm going to select tangent as my mode of operation. But I don't know the angle, so I have to leave theta there and say, well, I don't really know what that is. But I know that the fraction is opposite over adjacent, which is 50 over 500. Now again, you could turn this into a decimal, look it up on the table, and try to figure out what angle it's by. But your calculators are all going to have a handy little feature in it. Because you're trying to undo tan, we're going to use this cool little button in the calculator that says tan, and it has a -1. That means inverse tan. And then we're just going to put that fraction right into the calculator. So all I have to do on these ones is use my calculator. Second tan. Make sure I'm in the right mode. I am. And then I'll show you what my display looks like. My display is looking like this. See tan to the -1. I did that by hitting the second button first and then hitting the tan. Now when I hit enter on this, it's going to spit out an angle, 5.7. That's a pretty small angle, but you would expect it to be a small angle because you're trying to cover, if you look at the height in this picture, there was only a height of 50, but this long stretch was 500. So we're not talking about a very tall triangle. It's just a really small lift in order to get up 50 compared to that 500. So I like what I'm seeing here. I'm going to accept that number, even though it's very small. It seems reasonable. A lot of the times this would be like an angle of depression problem or something like that. So we can see all three examples. We use sine because it was opposite over hypotenuse that had our given information. On this one, we use cosine because I gave you an adjacent and a label on the hypotenuse. And then on the last one, we use tangent because your two given pieces of information were opposite and adjacent. So that's everything you need to know in order to solve trig. Enjoy doing your problems.